We were talking about piecewise and greatest integer functions, and we want to be able to graph piecewise functions and write piecewise functions from a graph. So whenever I'm graphing, I always want to start with the restrictions on the domain. And in this case, we only have two restrictions. We have equals to 0, and we have wherever it's not equals to 0. So not equal to 0 says that this graph right here exists everywhere except 0. And equal to 0 says this graph only exists at 0. So we already have this, our restriction drawn, but I'm just going to remind myself. So I'm going to draw where the domain is restricted. And it is only restricted at x equals 0. And we want to put our graph in here. So we got 5, -5, -5, and 5. And so this one says everywhere except x equals 0. And so when I graph this one, because it's an absolute value function, I'm going to graph it using the vertex and the slope. So we can remember that the general form of an absolute value function is y equals a times the absolute value of x minus h, absolute value plus k. And h and k were going to be our vertex. So when we look at this, our h value is the value that we substitute in here. So there's already negative and already negative. In order to make sure that stays negative, that means that we substituted in a positive 4. Remember, even though it looks like it's x minus 4, because the negative sign was there originally, that means we substitute in a positive 4. And there's nothing at the end here, so really that's like saying plus 0. So our vertex for this graph is at the point 4, 0. So we'll go over to 4, 0, and we will put our vertex right there. The next thing that we have to look at is the a value or the slope. And if there's nothing written there, then we know that the a value is equal to 1 or understood 1. So we got our slope and our vertex. So our slope means that we go up 1 over 1, and we're off the graph now. And because it's absolute value, our slope this way is the same going back this way, except for we're going in the opposite direction. So up 1 over 1, up 1 over 1, up 1 over 1. And now we get to this domain, so I got to look at it and see what it says. This says this graph exists everywhere except when x is equal to 0. So when x is equal to 0, up 1 over 1, this graph does not exist, and then it exists again. So when we go to graph this absolute value function, we know that it's going to be that V-shaped, but we have to make sure we don't include where x is equal to 0, because that's restricted on the domain. So we have our graph drawn here. And this is the function f of x is equal to the absolute value of x minus 4, and then plus 0. And it's restricted on the domain. In this case, x cannot equal 0. So that's the only spot it's restricted, so it's graphed everywhere else. Then we have one more to check. The only place we can check this one is when x is equal to 0. So we'll go ahead and do that. So we'll find the function f of 0 is equal to negative times the absolute value of 0. Absolute value is 0, 0. So negative 0. Negative 0 is just equal to 0. So we have the ordered pair, 0, 0. 0, comma 0, and that's going to be a closed dot because in this case it says x is equal to 0. And that is all that we can graph for this piecewise function.